here's the simulation we're going to be discussing. But first, some context. In college, our statistics professor introduced the Poisson distribution using a real-life example. After the end of World War II, an actuary divided a map of South London into 576 equally sized squares. The map contained points of impact during the flying bomb attack of 1944. He then counted the number of bombs that landed in each square. The number of bombs per square was shown to follow a Poisson distribution. So what's a Poisson distribution? The Wikipedia explanation is predictably dry. The Poisson distribution is a discrete distribution of the probability of a given number of events in a fixed time or space if events occur with a constant average rate and are independent of each other. How does this line up with the London bombings example? The independent events that occurred with a constant average rate were the bombings, and the fixed areas were the squares they divided London into. It can help with intuition to see ideas play out visually, so I made a simulation in Python. And because simulating bombings is bleak, instead it simulates birds pooping on cars. Here we have birds flying over a car park and randomly pooping. The blue circles are the birds, the blue rectangles are the cars. If poop lands on a car, it's colored red. In Poisson terms, the cars are the fixed areas, and the number of poops that land on each car are the independent events. The simulation keeps running until there's as many red poops as there are cars, as this will give us an average of 1 poop per car. Looking now to the graph on the right, we use this average of 1 poop per car as the rate parameter required for the Poisson's probability distribution function. This probability distribution function represents the probability that 0, 1, 2, or 3 poops will land in a car. Each of these probabilities is multiplied by the number of cars in the parking lot, which gives us the expected number of cars with that number of poops. The simulation has roughly 110 cars, so around 40 cars are expected to get 0 poops, 40 get 1, 20 get 2, 5 get 3, and so on. This expected number of cars per poops is what the line chart shows. The bar chart is the observed number of cars with that amount of poops. The number of cars needs to be large to reliably converge on the distribution. They had over 500 squares in the London bombings example, but here we're only using around 110 cars. Is there any takeaway message from this? Not really. The London bombings analysis was done because bombs appear to cluster together, and military intelligence were curious if this was intentional. By showing that the number of bombs per square followed a Poisson distribution, the actuary was able to prove that any apparent clusters were there by chance. For practical advice, you can always look to Bayesian statistics. If you're driving around and find a parking spot with bird poop on the ground and a tree full of birds above it, maybe consider parking somewhere else.